Hey everybody, this is Anthony Cox with Community Housing Partners in Christiansburg, Virginia. I work at the training center here. Been here about 20 years, weatherization about 30 years. So sure wish could be out there with you all and in Austin if we'd had a conference this year and try to do this virtual thing. So I hope everybody's doing okay. We'll get through this, I'm sure, and learning new ways to do stuff, and so hopefully this will be a good video, and you guys will get some information out of it. Like I said, I really enjoy coming out to Energy Out West. I always enjoy the folks out there, and we get to do some some hands-on and some field stuff. And unfortunately, we won't be able to do that, but we'll be able to do a little video here with my house of pressure. So this is one of the models that I use for training. Some of you probably seen me. I bring it out there pretty frequently, and do some training so you can get some kind of visual concepts, instead of just PowerPoint slides and some things like that, which those are all helpful on the theory, but sometimes we learn, when we can see the visual stuff. And so I call this, the house of pressure, or we can demonstrate, house as a system concepts, when you do something in one part of the house and affects something else. And of course, in weatherization, we're always, tighten the house up, or adding insulation, making homes more efficient and those types of things. But also, you may have, moisture, combustion, all these things, you have to deal with as well. Heat, air, and moisture. We have another little house we use for that called the ham house, and kind of do some demonstrations with that. But you have to keep all those concepts, in mind. You also have to think about pressures, because pressures, create airflow. If you've got a hole and a pressure difference, you can get airflow. And then that air, it might be moving combustion gases into the building, car exhaust gases, could be moving moisture from the outside, those types of things. So if you make the house tighter or leakier, the pressures change and affects where the air is coming from and that kind of stuff. So what we'll be doing here with the house of pressure is mainly things what I call non-blower door things, which is really more about with the exhaust fans, duct leakage, and door closure. It's also called like a mechanical air distribution. John Tooley and Neil Moyer, they coined that, back in the late 80s, early 90s there. So mad air. But we'll be doing those kinds of things in effects, in the house. And so on the house itself, I have different parts of the house here. I'm going to switch over here. You see like the parts here. This is like the bathroom, and you see as I have a bathroom fan in there that should light up for me there. I have the bathroom fan. Over here we have a living room. In the living room here I have a fireplace here. You'll see that come on. And then it's got a little smoke generator in there, and that should pop up in there, and we should be able to see some, flue gases go out the chimney there. I've also got like a little close-up camera here, so we can see close-up view there. We've got a little manometer in there we can use to measure pressures, those types of things. So those are pretty cool. Then we have a kitchen exhaust fan in here. I'm going to turn the fireplace off. Got a kitchen exhaust, which is going to be up here in this area. Sorry. Right here we go. Kitchen exhaust. And then I'll close that, turn that off. And then over here on the far right, we have a bedroom, which has a supply duct in it, and it has a door that we can open and close, as well as the bathroom. They both have doors. It's got a little fishing string right here. We can open and close that. I'm going to leave it open. We have windows, in the house, and they're all magnetic, so we can open and close those. And then moving down to the basement area here, you can see that we have a furnace here, and we have return duct leakage and supply duct leakage. I'm going to turn it on. You can see that. So you got the supply over here, here, and here, and then you got a return here. I also have a little smoke generator here. I'm sure a lot of you have something, similar. So what you're going to do here, I'm just going to squeeze that right there, and hopefully you can see that, I believe. And then I'm going to put this over the return first. and it'll see smoke actually going down in the return. Over here is the supply, and it's actually going out pretty quick. You can't see it so much. You can make leaks in the duct here. So if I go down here, it'll actually pull the smoke, in the return leaks, those kinds of things. So, and we have dampers. We can control how much air goes to each room and stuff. But the forced air duct, you can see how it affects things and stuff when we talk about duct leakage and door closure, those things. So as far as, like I said, I have a manometer there on the inside, and I can actually show that, as a larger screen there, as well. So we can see that and see the outside of the building. Let's see here. So I want to, I also have, one gauge we have in there is a DG 700, that's the Energy Conservatory. They also make some other manometers that we use quite frequently. These would be a Retrotec DM32. They're all digital manometers. Another one that we have is the Energy Conservatory model, the DG 1000. And they're basically, digital manometers. They have multiple channels, and you can use that to measure pressures and just get an idea of what's going on in the building. Of course, if you got pressure and flow, like we talked about before, get an idea of where things are going to. And so, but I can turn that on and off, like I say, if we want to see the close-up view of the pressure. And we may move the manometer around in the house at different times. But so anyway, we talked about the parts of the house there a little bit. I do have down here in the basement. I didn't show this yet. This is a my little water heater. So I could turn on a water heater here, and the water heater will turn on. I have a little door down here I can open and close for like a window. The water heater should come on. There goes the water heater. Then we have a dryer here as well. I can turn the dryer on, and you can see the dryer. And real quickly, I can just put, you see how the smoke's going out the chimney. But if I put where my hand is here, if I start closing this up, depending on what's going on in the rest of the house, it might affect the smoke going out the chimney. Let's see, we'll talk more about this later. I just want you to kind of see how that can happen. Basically, I was tightening the house up there when I closed that window, but now I'm going to open the window, and then you'll see the smoke goes back up the chimney. But we'll talk about the pressures. I just wanted to give you a quick little demo of that, and then I'll go back out here. So we also have a little garage in the bottom left over here, so I'm going to turn that on for you all. You can see that. I've got a little camera view. We'll switch down to there, and we'll see what that looks like. Here we go. Get that to come on. Fired up. Get the car fired up there. The little car exhaust going on. Kind of fun to play with. So switch back out to the main view here. You can see it kind of fogging up down there a little bit. Now, there's me there. I'll put this back on here. I'll turn that off. But you can see, if you've got exhaust gases in that area and a negative pressure, it could be pulled into the house. If you've got ducts or air leaks into the building and stuff like that. So turn that off. And so what I want to do now is I want to talk about exhaust fans and door closure and duct leakage and those types of things. So the first thing is, like I said, if you got exhaust fans, they're sucking air out, and we use those a lot, in weatherization, home performance. You have dryers, bathroom fans, kitchen fans, ashtray fans, and a lot of times that gets put in as exhaust-only systems. So, if those are sucking air out, that means it's got to have air, come in from somewhere else. So if you got 100 CFM going out, there's got to be 100 CFM coming in. So I can use, my little fireplace to show some smoke, so we can kind of see, the effects on things like that. And then I have the manometer if we want to measure the pressures and show the pressures. So what I'm going to do first is I'm going to turn on the kitchen fan up here. Actually, I'll turn on the fireplace first, and we'll see how this goes. So I'm going to turn on the fireplace. You'll see that come on, and then I'm going to turn on the kitchen fan next. But what I'm going to talk about here is I've got this window off, first of all. The window's off, and so the smoke's going out the chimney pretty easily. I'm going to turn on exhaust fans. Like I say, if they're sucking air out, they got to bring air in from somewhere else. And in this case, the fireplace is kind of that indicator of that. If it's sucking on the chimney, you know, as the house gets tighter, you might see the smoke come back in. But right now, we've got a really leaky house, and you can see the manometer, the pressure inside there, you know, as well. So if I go back out here, you can see inside there that there's zero pressure there. And then I'll go back inside here, and then I'm going to start turning on the exhaust fans. Here's the kitchen fan. Here's a bathroom fan over there, and then down on the bottom is the dryer. All of those are sucking air out, but it's really easy for them to pull air in through a really leaky house. You know, they can pull it in through leaks in the building and stuff like that. But as I start to tighten the house up, you know, then that can start to make a little bit of difference, you know. So what I'm going to do is I'm going to start, you see the pressure there is zero, and I'm going to start closing this up, and we'll see what happens. As we start to close the window, you can watch the pressure, and you can watch the smoke. And remember, those exhaust fans are sucking air out, and right now they can bring it in through this big leak. And as we start to tighten it up, and we got a combustion appliance here, and this combustion appliance also takes its air from inside the house. As we tighten it up there, you know, you can see, you know, it's starting to backdraft. So, you know, we got a little bit of theme music here, but you can see the smoke is actually now coming in the house, and that's a, you know, that's a bad thing. You don't want the smoke to come into the house. And we didn't even touch the fireplace. It could be a water heater, it could be an atmospheric furnace. But we affect the pressure in the house. So we tighten up the house, we add more exhaust fans, or the exhaust fans we actually been them out. So all those kinds of things. And then if I take the window off, you know, the smoke should turn around and go back out. And then if I close it back, you'll see here how we close it back. And as I start to close it back, you see the pressure start to change. Let me go to the inside camera there in the living room. You can see there, you start to come back inside. And I take the window back off. Window is off. Smoke goes out. Now I'm going to put the window back on, all the way on. As soon as I do that, you see the smoke comes directly into the building. So I'm going to turn off my little clip there, a little audio clip, so you can hear me a little bit better. But on the back of the house, so you can't see me around the back, but there's a little door. You should be able to see this. There's a little door on the back of the fireplace here, and that allows it to take air from the outside. So when I took that door off, you see the smoke go up the chimney. And now I'm going to put the door, right there's the door, I'm going to put it back on the fireplace, and you'll see what happens. Because when I did that, that forced the air for the fireplace to be coming from the inside, not from the outside. So when I have the window off on the outside, when I take it back off, that allows the fireplace to draw its combustion air from the outdoors. And then the smoke goes back out. So, and then I'll close it back. So you can see that pretty good there. So I'm going to turn that off. And now, so you see how the exhaust fan now, and the manometer, of course you can see the manometer there, we're at minus 2.5. And I'm going to take as I open or take the window completely off. So as soon as I do that, the pressure gets relieved. So like you saw there, we didn't have a problem with the smoke going out the chimney until we tightened up the house. So it's really important to do combustion safety testing, you know, when you have combustion appliance, and make sure smoke goes up the chimney. Of course, you're also doing visual inspections and the venting and the chimney and caps and clearances and all that stuff, which is very important as well. And so you have visual and diagnostic testing, and for lots of things. And but in this case, you know, the smoke started coming back down the chimney in the fireplace. So you'd want to do like for water heaters, gas furnaces that take combustion air from inside the house, you want to do what's called a CAZ test, combustion appliance zone test, where you go through and turn on all the exhaust fans and door closers. And we'll probably get to do that, like a little quick scenario that what we're doing here is just kind of putting the pieces together. So this just shows you how exhaust fans can affect, you know, the pressure and stuff in the building, and maybe combustion appliances if you have those. If you got an all electric house, you know, that's good as far as smoke going out the chimney. You may have some issues with, like say, if you got an attached garage or something like that, or you got a humid climate, you know, then you might be bringing in excessive moisture and stuff like that. So still pressures and stuff can still be an issue even in houses that don't have combustion appliances. You know, if you've got other issues in the house. Of course, car exhaust would be, you know, a combustion appliance. So I'm gonna put this back on, and as you see there now, as soon as I put that back on, the pressure went more negative. So I'm gonna turn off all the exhaust fans. Then I'm gonna turn them back on individually. And so I'm gonna turn them back on. So now when you're measuring, I got the manometer in here. I didn't really mention that. It's measuring pressure between the house and the outdoors. So that's the pressure that you're seeing. You know, so when we turn on exhaust fans, it's sucking air out of the building. It's making the house go at a negative pressure. So it's a lower pressure than outdoors. So that means, and high pressure goes to low. So if indoors is at a low pressure, that means outdoors is at a higher pressure, and anywhere there's holes, air is going to come in. Just like with the blower door. You all use blower doors, you get it up to 50 pascals. You know, when you get that pressure up, then the air starts coming in, you know, those holes. And the more fans you turn on. So if I turn on the kitchen fan here, I'm going to turn just the kitchen fan on. And let's see if it changes it a little bit. And then I'm going to turn the bathroom fan on, which is over here. Changes it a little more. And then the dryer. Again, we're measuring pressure from here compared to outside. And the dryer, we're going to turn that on here. And the dryer is all the way in the basement. Let's see if it affects anything. I'm going to turn it off and back on just so we can see that one again. It did change a little, went from 2.8 to 2.9. So, and then I'll turn all of them back off. One important thing also is, like anytime you're measuring pressure to the outside on your manometer, that you want to do like a baseline setting. And so like on the, this is for instance on the DM32 gauge here, they just have where you go to settings, and then you go to the baseline here, and then you set capture baseline, and then you can see there it tells you how long it's been counting. And then when you're done with that, you just say in capture. Typically you wait about, you know, 30 seconds or something like that. You just really want for it to get steady. And then you hit in capture, and so now it's stored in there. And then the baseline, it actually shows right there. So what that does is, if there's like pressure on the building from like wind or stack effect, you know, before you even do your test, so you might be at a minus. In this case, it was a minus, or actually it's a positive 0.8, but I was just kind of moving the manometer around. But they might be a pressure between the building and the outdoors. And when you do that baseline, it basically neutralizes that. So if it was at -2 for your baseline, and then you zeroed that out, or you did the baseline, then it would basically just, it would show 0. Versus you saying, having to say, well, the initial pressure was -2, I turned on the fans, now it goes to -4. I have to take -2 from -4, so okay, the pressure change is only -2. Whereas doing the baseline function, it basically sets that to 0, so that when you turn things on, you're going from 0, you know, to -2 instead of having to do that math. So it does the math for you, which is pretty cool. And all the gauges have that. You know, they just have the different ways to get to it. You know, I showed you on the DM32, the DG700. You know, you got baseline, and then you hit start, and then once your 30 seconds is counted down, and you hit enter. Similar on the 1000 gauge. But anytime you're measuring pressure between indoors and outdoors, and when you do that baseline, you have all your exterior windows and doors closed, all your interior windows, all your interior doors open, and then all your mechanical equipment, it would be off as well. So that way, and sometimes you get a trick, you'll get like an attic fan or something that's on, and it'll be messing with you because it's in the summer and it's set on a temperature. And if you got leaks between the attic and the house, it can be affecting the pressures in the building. So if you're getting something weird, and I've had that happen before too, I kept getting like a really high baseline, and it was like really strange, and come to find out it was an attic fan, that it had gotten hot enough to turn on an attic fan with a temperature sensor, and there was a lot of leaks between the house and the attic, and that was actually affecting my baseline. So I had to go up and disconnect that. Is what I ended up doing. It was easy to get to. But anyway, so baseline's important. So anyway, so I showed you exhaust fans. So next thing we want to talk about is duct leakage. So duct leakage, is very important, because if you have duct leaks, then you can be losing your heated and cooled air, to the outdoors. You can be creating pressure problems, just like we talked about. It can have any problems from, combustion safety, indoor air quality, durability, all those things. We mentioned efficiency. So duct leakage is your conditioned air. And when you have a duct leak, we talked about that you have air leakage. You got to have pressure and a hole. I mean, I can have, like I say, a little hole in the house here. I got some little tiny holes in here, but I could have a hole in the ductwork. Let's say the hole is, let me get it up here. This is about that big, and let's say I got one in the side of the house and one in the side of a duct system. Which one do you think is going to leak the most? The one in the duct, and that's because it's got a furnace fan on there. It's got a higher pressure. Of course, the house is going. It may leak some when you get windy and stack effect and stuff, but the duct system, when it comes on, it's pretty much always going to have high pressure, so you're going to have more airflow through that. Plus, like I mentioned before, that's the air you're paying to condition, so you really want to make sure you got your ducts sealed well. I mean, you can do pressure pans. You can do duct testing, similar to a blow door where you tape off the ducts and test the ducts, that kind of stuff. So let's just turn on some things. The first thing I'm going to do is I'm just going to turn on the air handler fan, which that's going to be my fan here. I got a little furnace fan in here. And when I do that, you'll see the streamers come on. And I believe I showed you that before. The smoke was going out, and then you have a return, the air's coming back. And and then I've got the doors. The doors are open. So essentially, you've got air coming out. This is what they call a central return system. They've got air coming out in every bedroom, because there's a supply in every room. And then right here's the supply. So, that may show up. And then the return, which is right here. Hopefully these will show up. And basically, I've got 3 arrows on my return, and I've got one on each of the supplies. So I've got 3 supplies. That's to represent the air going into the room, those little arrows. And then on the return, I have 3 arrows, and that's to represent the return. I only have one return. It's what's called central return, and that's pulling back all the air for the whole system. And ideally, it should be balanced, And so, but if you got duct leakage or door closure, you can have some issues with that. And older houses may have returns in every room, so you might not have some of the issues that I'm going to show here. But if you have a central return, like in the hallway or in the upstairs or downstairs, it might be in the hallway ceiling. For mobile homes, your return is typically, in the hallway. You've got what's called an alcove. You got a unit kind of in like a little hallway kind of closet, which may or may not have a door on it, but even if it has a door, it should have a louver that pulls air from the hallway. But the thing about those, same deal, you have on the mobile homes, you have supply air that blows into the bedrooms, but then it's got to get underneath the door, back to the house. You can also have, obviously, duct leakage on mobile homes or manufactured housing. A lot of times you don't have a return duct in those cases. It's just the return is at the unit. So most of your duct, pretty much all your leakage in a lot of those cases, they're going to be supply leaks, especially where the unit might connect to the ductwork. So what I want to show here is, you can see the manometer in there, the manometer reading, and I'm going to go back out here where you can see it. Let's see here. That'll show up. There it is. You can see that the pressure there is basically 0. I've got the air handler on, and there's no pressure, in the difference. So what I'm going to do here is I'm going to open up the supply leak, which is over here on the far right. And I'm going to go down here. I've got a little leak. And so what's going to happen is, or what should happen is, you'll see, watch these streamers as I pull the leak open. And then you can also watch the pressure as well. Let's see what happens with that. So what happened to the pressure? You can see that the pressure, I don't know if this is going to work or not. I'm going to point to my manometer that's overlaid. So we're like a negative number there. So we have a negative number. You saw that I opened a supply leak. And so it's actually making the building suck. And an easy way to remember that is supply leaks make the building suck, basically, is what's happening. So supply leaks suck. But you can see the streamers here, they stop moving. And I'm going to put the plug back in, and let's see what happens. Put the plug back in. The pressure equals out, and now the streamers work. Now I'm going to do it also. I didn't have the fireplace on, but let's turn the fireplace on, and you'll be able to see these pressures, you know, from the smoke going up the chimney. So let's see what happens here. Let's turn on the fireplace. You see that the smoke is going up the chimney at this point, and I'm going to make that supply leak, and we noticed it made a negative pressure, and we'll see if it affects the chimney. So I'm going to open up that same supply leak. Let's see if it makes a difference. Yeah, so it actually pulled the smoke back down the chimney there. If I put that back in, as soon as I put the leak back in, the pressure starts to equalize again, and now the smoke goes out. I'm going to do that one more time. So I'll make a supply leak. So that means that the air is blowing out the supply leak here, but the return's over here. So basically, I don't have this right here. I take my marker right here. So now we have no air, very little air going into this bedroom. But the return is still looking for the air that's coming out of the bedroom here. And in this case, it's pulling it from the fireplace. But if I take off the door here, you know, you can see that now the smoke goes back out the chimney because now it has a pressure relief there. If I put it back on, you can see how it goes back down and how we're like a minus there number there. And then when I take the window off, you can watch the manometer pressure, you know, behind my head, that it goes back close to neutral, you know. So now the smoke, you know, would go back out the chimney there. I think my smoke's about out of my fireplace there. I had to give it a little help. So, but you can see how it's going out now. And then when I close this one more time, you can see how it backgraphs. So I'm going to turn off the fireplace here for a sec. So I'm going to put fix the supply leak back here. Smoke goes back out the chimney. So now we're going to do a return leak, and so we'll see what happens to the pressure when we do the return leak. So I'm going to take, you know, I'm going to put the air back. I'm going to draw the arrow here, so now the air knows where to go. It goes back into the building, not into the basement and out the house. But now I'm going to take some of the air from the house and make a leak down here in the basement. And so I'm going to make a leak here, and we'll see what happens to the pressure. You can see the manometer. When I open that leak, I opened a really big leak. What happened to the pressure, you know, in the building? It went positive because now we're blowing more air into the house than we're pulling out. And then if you notice, the fireplace, is it working now? It's working really good. You know, the smoke is just flying out the chimney. So burning a lot of wood real fast, but you know, not that you maybe have them both on at the same time, the fireplace and the furnace, but you could. So I'm going to put the leak back in here. Seal it back up. You see how it kind of slowed down. It goes out at a slower pace now. And then the manometer reading, you see how it bounced out. So I'm going to open that back up. You see how it goes positive. So now, down near the leak though, down here in the basement area where the leak is, you know, what's going on in the basement area down here? So if I'm going to take my smoke pencil right here, I'm going to take this, and you can see what's happening. It's actually pulling the smoke in. So the main part of the building up here, it's under a positive pressure, but where the leak is negative. So anything that's in that space, first of all, if you got a return, it's in a crawl space or an attic, it's pulling in the air from those spaces, and you're having to heat and cool that. If it's in a dirty location, you know, you're also pulling in indoor air quality issues. You might be pulling in fiberglass, dirt. What if this system is in the garage? Would that be a problem? So if it's in the garage and you had a return, you're in the garage, and any kind of leak, that means that anything from the garage gets pulled into that leak. So if it gets pulled into here, goes into the furnace, And then it goes, right back into the house. So anything that's in the garage is now, in the house, if you've got duct leakage in those areas. So I'm going to close this back up. The pressure you'll see will start to go back close to 0 again there. And same thing as before though, if I had a really leaky house, let's make the leak back. If I got a really leaky house, you'll see that when I open the window here, that pressure doesn't even show up, until you make the house tighter. Now, so I'm going to put this back on, put the leak back in here, and then we're just going to recap here real quick. And you all can see the manometer. And I'm going to make a change in the house here, and we'll see which is leaking. So I've got the window on. I got the interior doors open. So I'm going to go to the close-up view here, and where you can't see what I'm doing. So I'm going to go to the, let's see here, go to the living room view. So now you can see the manometer, and you can see the fireplace, and you can see which way the smoke's going. So you can see the pressure and the smoke. And I'm going to make a change in the house, and you should be able to know which side of the duct system I made a leak in. So I made a change, just a small change. What happened to the smoke? The smoke's now going, it's not coming back in, so that's a good thing. It's actually going out a little bit faster. It's actually a little bit of a positive pressure. So I actually made a return leak. And what I did is out here, as I got a little wheel right here, and I made just a small leak, not a big leak like I made before, but it's enough to affect the pressure where the smoke is going in there. All right. So now let's turn that back, fix that back. We'll go back to the inside one more time on the living room here. Now smoke's going out. I fixed the return leak, and we're about 0 pressure. So now I'm gonna make a change here, and we'll see what happens. Made a big change that time. The house went negative, or the building's sucking. So what kind of leak do we have? Got a supply leak. Supply leaks make the building suck. And so I'm going to go and put the, go back here on the outside. So I made the same leak that I made before. I also have one over in the garage. I could have done the same thing. As soon as I plug that up, pressure balances, smoke goes out the chimney. So you can kind of see how all those things get affected just from duct leakage, and all the indoor air quality, health and safety, comfort, and durability. If I've got negative pressure, we could have moisture issues, that kind of stuff, as well. So I'm going to shut this off. Right, so I've got everything back off here now, and so as you saw kitchen exhaust or bathroom, you saw exhaust fans, and then we saw duct leakage. And when you do that duct leakage, it's actually a test called the dominant duct leak test. And the dominant duct leak test is basically you set up the manometer like I showed you before. You do a baseline test. All your interior doors are open just like you would for a blower door, kind of like natural conditions, or some people call it winter conditions. And then the only thing that you're turning on is the air handler fan. And you're going to notice the pressure change between indoors and outdoors. And so when we did all this demonstration with the duct leakage, the only thing I had on other than the fireplace to show the smoke was the air handler fan. So basically you could go into a house, set up in your natural conditions, put your manometer hose to the outside in the middle part of the house, and then do your baseline, and then turn on the furnace fan. Sometimes you can turn that on directly. Other times you have to turn the heat or the AC on to get the fan to come on. It depends on the thermostat. And if you got AC, you want to turn the AC on, you can see the kind of the biggest pressure. Just turn on the fan, watch your manometer, see what the pressure changes. If it goes negative, then we know we got more supply leaks. If it goes positive, then we know we got more return leaks. But there may be other times when you get a 0. So if you get a 0, it basically could be one of 3 things. It could be that there's no leaks, which is usually not the case. I mean, newer houses now, they're getting better at tightening ducts, so that might be on a newer house. But another reason you might get 0s if you have equal leaks. You've got supply and return leaks, And the third reason, and I would say probably is more likely in a weatherization home, would be that the house is too leaky to hold the pressure. So if you do a blower door test and you can't get 50 on the blower door, with your house pressure, then turning on an air handler fan is not going to make much of a pressure difference. So, but when you tighten the house up, then those things might start to show up more. Of course, you're going to do a visual inspection for duct leakage. You probably do a pressure pan, and you may do a duct test and see how the leakage is. And then you will compare that to your standards and seal it up and those types of things. But a dominant duct leak test, it really just lets you know if you're getting any kind of big pressure changes. I've had homes where I turned on the air handler fan. They had moisture problems in this home. And I noticed that when I was doing an infrared, that the image changed on the wall when the air handler came on. And in other words, it showed that like outdoor air was coming in, just like when a blower door, when you use a infrared or a thermal camera, you'll see air coming in, or you'll see an image of where the air is making a surface warmer or colder. And this is what was happening, but the blower door wasn't on, the air handler was on. So I said, hey, we got duct leakage here. So what I did is I set up this dominant duct leak test, and I measured the pressure. All I needed was a manometer, and like I say, turned everything off, did the baseline, turned the air handler fan on, and we were at -5 just from the turning the air handler on. So if it was at -5, turns out we had a supply leak. And then this is in particular was a manufactured home, and they had put a package unit on for the heating and cooling. So it's basically two ducts that come in, and one went to a return, but one went to the main supply line that went down to the manufactured house. And what happened was underneath when it got installed, it didn't get installed very well, and there's like a 10 or 12-inch duct, and part of it was not connected. It had failed down. And I actually ended up doing a duct test later, and it come up about 350 CFM of leakage. So, but essentially, what was going on with that was it was depressurizing the house. It was pulling in hot, humid air. In this particular home, they kept it relatively cold, like 70 degrees or less. And so when that warm, moist air come in, it was condensing. But I saw that with the infrared, and that what made me think about the ducts is when the air handler came on, it changed that image just like a blower would, and then I went and did my dominant duct test. So sometimes, you may not always do a dominant duct test, but it is very handy to know if you've got like a large, supply or return leak, those types of things. So sometimes, I go out and do consulting. It's not just a weatherization job. I'm kind of going out and looking for these kinds of issues. So the next thing I want to talk about is door closure, and then we'll do that, and then we'll kind of put all three of these together, and we'll talk about like a combustion appliance zones scenario. All right. We finished doing the duct leakage and the kitchen exhaust. We're going to do some door closure things here, and like I said, when you've got a central return, that can really closing doors can affect the pressure. It's kind of like duct leaks. They're cutting off the airflow from one area to the other, and we'll do some little demonstrations of that, see how it affects the pressures, and maybe talk about some solutions and fixes for that. So anyway, so I'm going to go back to the house here, and on the house, we have the bedrooms, and in this case we have a bathroom, could be a master bathroom, and we have a living room here. So those are the three supplies, 1, 2, 3, and then the return is here in the middle. And everything works good. I'm going to turn the fan on here. You can see it come on. And the air's coming out like we had there before. I got my little arrows. The air's coming out. And as long as the door is open, the air comes out of this vent. Then it goes out the door, through the door, back out into the return out here. So that's how that works. And then so that goes like that. And then on the other side, same thing over here. This goes, from that room back out into the main hall there, into the return. So what happens though when you start closing the doors? When you start closing the doors, then again, depending on the tightness of the house and the individual rooms and how much airflow is going into the room, it can create some comfort problems. It can also create enough pressure to maybe cause some backdrafting, maybe like a water heater or something like that. And I'll turn my fireplace on to represent a combustion appliance. It gives you just kind of a visual example. and then we'll also look at the manometer at the same time, and we'll see how that door closure affects things. So right now, I have just the air handlers on. Interior doors are open. I'm sorry, the master bathroom over here it was closed. So I got it closed, and then the bedroom, like I say, it's open here. Furnace fan is on. You can see that the streamers are on. No leaks, all that kind of stuff. And you can see the manometer reading in there. What we're reading is the number on the left. You know, and that's the one in the living room there. And basically, the air handler's on. There's no pressure difference at this point. But then we're going to start closing the doors. So right now, I'm going to reach in here. The bedroom door, I got, like I said, my little string right here, so I can close this door. So we're going to watch what happens to the pressure in this main part of the building here. And we'll watch the pressure first, and then I'll do it with smoke. Maybe that's the way we'll do it. So I'm going to close this, and you think about what might happen, because like I say, now we got air that can't get back to there, so this return is going to be looking for it, almost like when we had a supply leak, okay? See what happens. You start to get a little bit of a negative number there. So we're like a -1, somewhere around there. So now, that's on the building. Now, let's go back out, and I'm going to close the one to the bathroom over here, and we'll see how it affects things. It's going to be the second door here. And now you can see that we're actually like about a -4 there. So from opening those, closing those two doors. And so now we're at -4. I'm going to open them back up. I'm going to leave it on this view so you can see. You can see when I open the master bathroom there, and then I'm going to open up the bedroom, and you can see how that affected the pressure there. And so if I turn the fireplace on there, we'll see the smoke go back out the chimney again with the fireplace like we did before. But if it's so strong enough pressure, it can cause backdrafting, as well. Because so when we start talking about CAZ testing, you start putting all this stuff together, you have to think about, okay, I'm doing my CAZ test, and everything was good until this happened. And so you want to know what this happened was. Was it when the air handler came on? Was it when the doors closed? Was it when the exhaust fans came on? Those kinds of things. So as you can see now, the smoke's going out the chimney, and I'm going to close the door just like I had done before, but this time I got the smoke going out the chimney. You see, it pretty much has slowed it down, started bringing it back in, even just from that one door. But then when I open or close the second door, again, remember this is a little model, so it doesn't take much, to backdraft it. So, but right now you see the smoke's coming in, and we're at a -4 Pascal. Now, if I open up the window, what happens to that? You can watch that -4, and as I open that, you see the pressure goes back close to 0 now, and now the smoke goes out the chimney. And again, as we tighten the house up, you start to see this get a little more affected there. And as I close it all the way, it gets even more negative. Now, and then if I open the doors back, if I open that door and open this door, it works fine. I'm closing back. And so if you think about, what's going on in the building, what kind of pressures? We said out here we got a negative pressure in the living room area. Got the door closed back there. And so what do you think might be going on in the bedrooms though? So the pressure in the bedrooms would be interesting to know if it's positive or negative. So if I put my hand right here, I can actually feel, the air coming out of this little hole, and the air's coming out there. I'm going to try to just put my little smoke puffer here. You might be able to see it. Let me see if I can get this to come on. But it's actually blowing back out and toward me. I can also, yeah, it's coming out there. I'm trying to think of a better way to do this. But I can actually take another manometer here, and I'm on the outside of the building. This number is going to kind of surprise you. Hopefully you can see this. That's 55. 55. So it's a really small house, and I got a lot of airflow going into that room. So now watch when I open the, I'm going to put this right here. Maybe that'll show up. We're in the 50s. Now that's the top number. Oops. That's the top number right there. And then the -4 over there, that's the pressure in the house. So in the living room. So I'm going to open this door. You can watch both of the numbers. So the 50, you see how it dropped down to basically 0, and then same thing in the house. They basically equalize the pressure. Of course, now my smoke's starting to go back up the chimney too when I open the door. And if I close it back, it gets trapped behind the door. You see the smoke coming right back down the chimney. If I indicated this with a plus sign here, then that's I got a little green screen, so the plus don't always show up. But anyway, you guys get the idea that it's positive there. Out here in the main part of the house here, it's negative. So if I was to go over here and open the door like I did a minute ago, you saw the smoke that go out the chimney. But also, that's pulling air in other leaks. So I mean, I'm just using the chimney to show, the airflow. But let's say there's no chimney; it's just all electric house. This is still can create issues because now this negative pressure over here is pulling air in from the outside. If it's the summertime, it's hot, humid air. So you're having to condition that, dehumidify it. If it's in the wintertime, it's cold air, and so you're having to again condition that, heat it up. Over here in the bedroom, if this room is positive, then it's pushing moisture, into the walls. So if you have a cold surface and you got air leaks in the wall, you could actually get some condensation and some things like that. So just by closing that door, and you may be in a house where the door gets closed to or gets sucked shut to a bedroom. You turn on the air handler fan, and then you hear a big slam, and the door is closed because there's a central return that's trying to get the air from behind that door, and then the door's almost closed. It just sucks it shut that final little distance there. And so, or you might see like a carpet in a house, and then the carpet at the bedroom door has got a stain on the bottom of it, and that's where air, if the door stays closed a long time, it's air trying to get out from under the door. So I'm going to open this door back up too, and then we're going to switch over to the bedroom there for a second. I'm going to turn my fireplace off. So, but what I want to do is I want to switch over to the master bathroom, and I'm going to show you measuring the room pressure. So, and room pressures, you can measure those you put a hose under the door and measure it back to what I call the main body, where the hallway, central area of the house is. And that's the way I've typically done it over the years. But you can measure it to the outside, and the difference is, if you want to know what the pressure is across it is to the outside, then that lets you know if you may be pushing moisture in or out of the wall there, the pressure on that wall. If you're measuring the pressure across the interior door here to the main body of the house, that lets you know that it's bounced to the house. So when you turn on your air conditioning or your heat, basically, even though that door's closed, it's acting like it's not there. If you got very little to no pressure across that door. So right now you may have a lot. If there's not much undercut, or maybe you've got too much air coming into that room. That might be if you have a high region, you might have a high number. But so in my experience is if you get that balanced, and the rule of thumb or the number that you hear a lot is plus or minus 3 pascals. If you basically you close all the doors in the hallway, you put the air handler fan on, you put a hose under the door, you measure the pressure, and ideally you want to be less than 3 to the house. If you're less than 3 to the house, you're going to be less than 3 to the outside. But you can measure that directly. You have to have a long hose, or there's some little math. I even made a little app to help do that if I wanted to know what it was to the outside, just by measuring the numbers to the inside with the dominant duct and the room pressure kind of thing. I put it all in one little app where you could kind of do a little bit of math without having to run a hose to the outside kind of thing. But most time I just measure it directly between the bedroom and the hallway, and I want to see that, you know, ideally less than about 3 pascals. So let me know that that's not creating a restriction. So what we're going to do is we're going to set up a manometer to measure that pressure. So I'm going to go inside the house here, or my hands are. So I'm going to go inside here. And so now we're back at the living room area, and I've got the furnace fan on still. Actually, let me just turn that off. And so that way it'll be a little less noisy. I'm going to put this where we can see the manometer. I also want it to be where you can see our master bathroom there. So I'm going to take that same hose that I had a minute ago, but I'm going to, the yellow one, well, I don't know if it looks yellow. Yeah, it's yellow. So it's yellow hose there. And what I'm doing with that is I put a hose on the top right, and that's going to measure the pressure between, this is going to go to the room. So this is going to go over to this room. And in my little model here, I have a little hole in the door, which makes it handy. I just thread that through the door there. You can see it. If you're at a house, you know, then what you're going to do is you're just going to slide that hose under the door, usually like 2 or 3 feet. You know, like I say, if you're at a house, you want to slide that under the door a good 2 or 3 feet, and then you want to, you know, shut the door on that hose, and then you would take your reading. You would do each room like that. So we want to do that for this room. We go back inside here. We got the manometer set up. Now the manometer on the left side here, that's still hooked up. This hose here goes to the outside. So that's still measuring the pressure between the house and the outdoors. This is measuring the pressure between the room and the house. And if you use manometers, you know, a lot of times they'll have the word REF, you know, input and REF. So with reference to, you know, you'll say one area with reference to another. In this case, this is the pressure in the room with reference to the house. This is the pressure in the house with reference to the outside. And we can, because the manometers, and most of them, well, all the ones that I use, have 2 channels. So you can measure both of these things at the same time. So what we're going to do, though, is we're going to turn on the air handler fan. I'm going to put the window back on. So I got the air handler fan is off at this point. And then I'm going to turn on the furnace fan, and we'll see what that number on the right will actually be the pressure between the room and the house. And like we said, the left will be the room and, sorry, the house and the outdoors. So I'm going to turn it on and see what happens. So the number on the right there, that's the room pressure. Just like we had like 50 something on the other one. This is not quite as bad, but it's still a pretty high number. But again, remember, we're in a little model house. I have seen numbers high as 30, you know, in a house that had a small bedroom, and then where that duct was configured, you know, it's close to the unit in the attic, and it just dumped a lot of air into that room. So in that case, you know, maybe instead of undercutting the door so much to relieve that pressure, we might reduce the amount of airflow by putting a damper, you know, on the attic, you know, go in the attic. In this case, it was an attic, and put a adjustable damper in the attic, not on the grill in the bedroom itself, but in the attic where you can damper it where it comes off that main trunk. And so in this case, you can see the house is negative there. And then what I'm going to do is I'm going to open the bedroom door, and we'll see what happens to the bedroom door. I'm sorry, the master bathroom. I'm going to open that. You can see me open it. And when I do that, just like on the bedroom door before, when I opened it, the pressure in the bedroom went down, and then the main body went down. So both of them kind of equalized. All right. And so I'm going to turn my fireplace back on here too, so you can see it real quick. I'm going to have the door open first, just like I did before. Door's open. Turn on the fireplace. We'll see if the smoke goes out. If I got any smoke left in there. Let's see. There it goes. Just take a second. Yeah, the smoke's going out. You can see that there. I can go back out to this view. You can see the smoke's going out. And now I've got this door open. So now I'm going to close this door, and we'll watch those pressures again. So I'm going to keep it on this view. Close this door. You can see my hose going into the door. I'm going to close the door here. The door is now closed, and now it's coming back down again. So what we want is the smoke, you know, to go out the chimney when the door is closed. So what you want to do is equalize that pressure. So you would open that up, you know, until the pressure drops. In this case, we're at 27 there, and I would open up the door until the manometer pressure drops. I'm going to turn this around a bit. Yeah, 28, something like that. Go back inside here real quick. Yeah, that'll work. You can see that there. About right there, that's good. Now there's the bedroom pressure on the right, the house pressure on the left, and I'm going to open the door, and as I open the door, we'll watch that 26, and that's the number we want less than 3. We were talking about. And you see, as soon as I start to crack the door, I'm opening the door now. You can see me move it over there a little bit. And as I open it, then you can see I'm already down to less than 3 right there. And what you want to do is when you open that door, let's see if it'll show up here. When the door is open there, you're actually measuring the gap of how far you had the door open. And then there's a little table that we'll use sometimes. So you measure the gap of the door, depending on how big the door is, you can figure out the net free area. And so on my little model here, what I did is I have, you can see it here on this side, is I have like a little, what we call a passive return. It's basically a vent in the wall, but I also have a vent in the wall on the other side over here. And what that allows me to do is to, when I close the door, it will allow the air to move from this room basically through the wall and then back out into the main body, even when the door is closed. Now, the easiest way to do this is probably just to undercut the door. They have these things called perfect balance. You can look those up online, but they're basically like little grills that go in the bottom of the door. They're called perfect balance, it's what they're called. And then Tamarack Technologies, Tamtech, I think you can find it down there. Probably other places too, but they work really well. You can paint them and stuff. So basically, it's like a little grill that goes in the bottom of the door. Other ways to do it, you know, like I say, you can go through the wall like I did here. And we don't put it like directly through the wall because then you would get, you know, sound and light transfer maybe. So you kind of put it in one high, one low. And usually you put it high in the bedroom because you might have like furniture there, it'd be above. And obviously you don't want any bypasses in the attic or underneath, so you want the air to move through here. No plumbing in the wall, stuff like that. So that's one way to do it. They have some that go straight through the wall. They have like sound baffles and stuff that you could probably use. Same folks there at the Tamarack Technologies. You could also put a grill in the ceiling here, a grill in the ceiling here, and then a jumper duct, you know, between them there. If you put a duct between them, and then that way, even when the door's closed, it can go over. You know, you know, I was talking about Thule in the Mad Air. He had this table, you know, had all the different ways to kind of do it. I called it 50 ways to leave your louver. So I know it's really bad. So that's one of my favorite bad jokes. So, but basically, you got to have a louver or some air, way to get the air from one side of the bedroom back out into the hallway, you know, if you're trying to relieve the pressure. So I'm going to put this back on and then close the door back. So I close the door back, you'll see the smoke go back down into the house. But now I'm going to take those little louvers, my louvers, right? My vents, if you want to call them louvers, fine. I got one on the bedroom side here. I'm going to take off. You can see that. Put the door back on. Go over here on this side. Take it off. So now I'm going to close the door, and ideally when I close the door now, the air would go through those vents or louvers and not be trapped behind the door. And the smoke should still go out the chimney even though the door is closed. So now you can see there, even though the door is closed, the smoke is still going, you know, out the chimney. And it's not down to 3, it's dropped some. So basically I probably could have put some more relief there. But anyway, you get the idea that you want to do this if you got air trapped behind the door. But this is like a door closure test. And you typically do this when you do your CAZ test and combustion safety, maybe along when you're doing the, like I said, the dominant duct leak test. But you're just wanting to know that the air, you know, can get from that room back out to the main body of the house, even when the door's closed. And again, it all goes back to all those main things we said there: health and safety, durability, comfort and efficiency. All those things get affected just by closing the door. So, and again, just like anything else, you know, the leaky house, it doesn't show up as much, but as you tighten the house up, you know, then it'll show up more. If you got a house that's got, if you got individual returns, then you're not really gonna, most likely won't have this problem. You know, you could still have some issues, but not like you would if you had a central return. So just being able to recognize that. And so what we're going to move to next is kind of combining all these things together and kind of doing like a little CAZ pressure test. You know, of course, the CAZ, I call it combustion safety test. You're looking at the chimneys, you're doing gas leaks, carbon monoxide, efficiency, temperature rise, you know, ideally even static pressure and things and stuff like that. But for what I want to focus on is just doing the CAZ piece. I'm just going to say that we have a CAZ like upstairs, and then we're going to go through the kind of like the steps, you know, to kind of making like a worst case scenario. Okay, that's what we're going to do next. I'm going to turn everything off and wipe the house down here a little bit. So I'll wipe this off here, and hope you all are still with me. You know, it's just not as fun as being in person, that's for sure. But we'll see how it goes. All right, so now for a CAZ test, what we want to do with that is we want to, like I said, go to natural conditions, or let's say winter conditions, where you've got all the equipment off, exhaust fans, air handler fans, you know, combustion equipment on pilot. If you got a water heater, gas water heater, or your thermostat's off, any combustion appliance. Like I said, you don't want those to fire up during this test. Same way you don't want them to fire up during your blower test. All right. So you're going to set up your manometer, you know, inside the house, or not inside the house, but where the CAZ is. So most time you would take your manometer, set it in the CAZ, and then when the CAZ is you've got it set up, then you do your baseline test, and then you'll go through each one of these steps, and we'll turn on exhaust fans, close doors, and see what the worst pressure we can get it to be. All right. So what I'm going to do here is I'm going to put this, I'm going to get rid of this hose here. We don't need that. And we just want to measure the pressure. In this case, we'll just say that this main area up here is our CAZ. It could be a gas water heater, you know, whatever. And it doesn't have, I mean, I got a little fireplace in there. But basically, if you got a combustion appliance that takes air from inside the house, you want to do this CAZ test, you know, which would be like a standard atmospheric water heater, 80% furnace, you know, older 70% furnace, all those items. You know, if you have a 90%, you know, steel combustion, you wouldn't have to do a CAZ test, but you still do your carbon monoxide, your efficiency and temperature rise, and those types of things. But now we're just going to focus on, we're going to say this is our CAZ up here in the central area of the house. I'm going to turn the manometer here, hopefully where we can see it. And if I need to move in every now and then, I'll do that too. I'll be able to just, you know, go right into the living room there, and we should be able to see the number okay. And that's the number we want to see. We got two numbers, but really the only one we need to see is the one on the left. And we're going to set this up to be CAZ with reference to the outside. So what you would do is you take your manometer, if you can physically be in the room with the CAZ, your combustion appliance, and you take the manometer in the room, you just run this hose to the outside. You can run it back through the house and out the blower door, or you could run it out a crack in the window, or use a little probe. You want to make sure you can shut the window back or exterior door. You know, you don't want to leave it open or cracked. You know, you want to be closed. And then in this case, you know, you can't see what the buttons are here, but you would do a baseline, and then you would, you know, and do all the steps for that to set your baseline, depending on what manometer that you have. Now, so I've got this hose. This hose, again, is going to the outside. So that's CAZ with reference to the outside. All right, so I'm going to go back out here. So there's the manometer inside. You can see the number, the zero there, number on the left. That's the one we want to focus on. I'm going to put this back on. So we have all of our appliances off. All exhaust fans are off. Interior doors, they all need to be open. And so I think we're ready to go. I'm going to put this little door back on the vent back on the interior wall here, where my pressure relief was. And No, here we go. And got everything set up there. And so what we want to do now is we'll just think about like a typical CAZ combustion safety protocol. Like I say, you got it in winter conditions or natural conditions. You did your baseline. Now you're ready to turn on your exhaust fans and see how the pressures get affected. And then we'll go through some door closure, air handler, that kind of stuff. So what I'm going to do first is I'm going to turn on the exhaust fans, what we call small fans. Some people call it the exhaust fans, you know, like a small fan, like kitchen, bathroom, dryers, and then like the air handler, sometimes they'll call that the big fan. So what you don't want to turn on, though, is the really big fan, which is the whole house fan if they have one of those in the hallway, and of course the blower door is not on. So those are always going to cause a huge negative pressure if you've got everything closed up. So you're just using the exhaust fans and the air handler fans. So what we're going to do is we're going to turn on the kitchen exhaust first, which is going to be up here. You see that come on, and we're at negative 0.3 in there. Let's see if I can get close there to it. So you can see it there, negative 0.3. Now the bathroom fan, you can actually see that in this picture, which is over there to the far left. I'll turn it on. You can see if we get any pressure change from that. So there's the bathroom fan. So you can see there it is now at a negative 2. These are all in pascals. I didn't mention the measurement that we use is pascals. I mean, it's like 250 pascals, 248, something like that, roughly in a inch of water column, which a lot of HVAC will use for duct systems and stuff like that. Now I'm going to go back out here where you can see me. I'm going to go down into the basement here, and I'm going to turn on the dryer here. Now the dryer, I'm going to turn that on. Actually, I'd have all the interior doors open. So in this case, we'll just call this like it's a basement / laundry room, but let's say it's conditioned space, and I've got the dryer down here. I'm going to turn it on, and we'll see if it affects the pressure upstairs. So we're at about 1.7. I'm going to turn it off, and then I'm going to go back to the inside view. So the inside view there, that's with the dryer off, and that's with the dryer on. So even though the dryer is located in the basement, even though the dryer's in the basement, it's still affecting the pressure upstairs. And of course, that depends on the tightness of the house. If it's a really leaky house, it might not have made much difference. But the tighter the house, even though a fan might be across the building, it might still make some pressure differences. Okay? Quite often it will. So that's each one of those fans are on. Now, the next step, though, is if you've got the exhaust fans on, is you want to close all the doors, basically close all the interior doors. And you're going to, the doors that have fans behind them, you're going to check and see if the pressure is worse with that door open or closed. And a lot of times the way we do that is we take a little smoke puffer and we'll puff smoke, at the bottom of the door. And if it pulls smoke under the door, then that means you want to open the door. So like for this bathroom, master bathroom over here, bedroom area, that door, when it's closed, if it's pulling smoke under the door, that means it's trying to get out here. It's trying to suck air from my CAZ. Okay. If I puff smoke at the bottom of the door and it doesn't get pulled under, then it tells me that I want to leave that closed. So same thing. Now the bedroom, though, at this point, well, all we have on is the exhaust fan. So when you check you don't need to check the bedroom doors, because if there's no exhaust fan behind it, then you just want to keep that door closed, because when you close that door, like I say, the bedroom door over here, I'll close it now where you can see it. There's no fan behind it. So basically, when you close this door, it reduces the volume of the CAZ. Whereas this has a fan behind it, the door to the basement has a fan behind it. We want to know, does it get, is it better or worse with the door open or closed? And we want to put it in whatever the worst position is. And the worst position means the more negative the number is, the worse situation it is. So I'm going to put the window back on, because I have a really leaky house, it wouldn't make much difference. So we're about minus 1.9 there. And what I want to do is I think I'm going to go back to this interior view. For the interior view here, you can see the fireplace, you can see the manometer, and you can see the door there. And so what I'm going to try to do is kind of simulate doing this smoke pencil here. I'm going to take my gigantic monster hand in here. You can see that. Now I've got this door, it's open. I'm going to close it to the master bedroom bathroom there, and they've got this little hole right here, and hopefully this will show up. But it's actually pulling the smoke, you know, in that little hole. Or if you was doing it at an actual house, I'm going to try to do this from here. Maybe you can see it. You might just crack the door open a little bit. And then you see it there. It's pulling smoke in the door. So that means when I open it up, it should make my pressure worse. So let's do that. I got to put my front window back on here. See, we're at -5, 1.45. I'm going to open up the door now. Let's see if it gets worse. It does, which is pretty much what, because now that you've got that door open, now the exhaust fan that's in the bathroom there, it can pull air from the CAZ. Now, the next one is the door to the basement, which is going to be, move this out of the way here. I've got like a little door right here that I can open and close. And I'll zoom back out where you can see where I'm at. So I'm right here. I got like a little door. That's the door between the main body of the house and the basement, in this case, kind of laundry area. So now, in this case, we have a dryer down here, and we want to know, is it better or worse with this door open or closed? So what we're going, or worse with the door open and closed. That's maybe the way to say it. So I'm going to go back to the inside view, and then let's see if I can't. You might not be able to see the door, but just, yeah, maybe you can. I'll try to get it where you can see both. So I got the front door back on now. So now I'm going to close that door. So when it's closed, it's like -3. And when it's open, it's only -2. So let's go back over here to my smoke puffer. See if I can't do this. If I close this door, I don't have a hole in there. I don't know if we might can make this work. But it's not really pulling the smoke in. And if I open the door, let's go back where we can see the number here again. You can see the number. If I open it, I'm sorry, I got the front window off. There's closed, so that's closed. The easiest way to do it is just look at the number. Some people will carry a manometer around. Or, I mean, most of the gauges now have a Wi-Fi or Bluetooth connection, so you can set your manometer in the CAZ and read that on your phone. So this manometer can be in the furnace room in the basement, and you could be opening the door on the other side of the house and read this number of the CAZ on your phone. So the easiest thing to do here is if I open it, does it go back close to 0 or does it get more negative? So let's see what happens. If it goes closer to 0, which it did, that means it's making the CAZ better. So worst case is going to be with this door closed. And part of the reason it was probably better, with the CAZ door, the door open from the basement to the CAZ, was when you opened that up to that area with the dryer, it was a huge bit of volume, you know. So basically, the exhaust fan didn't make it worse, but the excess volume in that room made things better. So right now, the worst case is with the bedroom door is closed. We smoked this door, went under, so we opened it. We smoked this door to the basement. It didn't go under, so we left it closed. And you can see the number there where we're at now is at -3. So the next move is to, in this case, our CAZ is in the main central part of the house, but occasionally you'll have a door, like you have a CAZ in like a mechanical room or something. Well, not occasionally, actually a lot of times. And so what we typically do is we'll just do a test once with that door open and once with it closed, you know, and record both of those numbers with the exhaust fans on. And then when we do the air handler fan, we would go through the steps of checking the doors, and then we would do it once with the CAZ door to the house open and once with it closed. And this example here, I don't have that, but we'll do one in the basement make a basement of CAZ, and you will have that, and we'll do that example. So right here, we're at -3. I'm going to turn the air handler fan on right now. And then once we turn the air handler fan on, we want to recheck the doors and see which is the worst case for those. So air handler fan, let me get back out where we can see it here. So that's off. You can see it, it's going to come on there. I had no duct leaks, so I mean, but I do have the bedroom door closed, and we're going to check the bathroom and the basement door. So let's go back inside here, and you can see there's the number. We're at 6.4 when we turn the air handler fan on. So that gives you a clue. Let's turn the air handler fan back off. Air handler fan is off. You know, we're down to 3, somewhere around 3, somewhere around there. And then when we turn the air handler fan on, it didn't quite double, but it was pretty close to double. So you can see there that now we may or may not have leaks. I mean, I know that I've got my leaks in my house here, but when you get a change like that, when the air handler comes on, it could be from door closure or it could be from duct leakage. In this case, I know I've got the bedroom door over here closed already. So I'm going to go and check this bathroom door, the master bathroom. I'm going to close this door back. I'm sorry. Can you see that? Yeah, you can see that door. I'm going to close it on the left side of your picture there. Close that door back. And now I close the door. Look what happened to the number now. So when we closed that door, it went to -14. So once your air handler is on, once your air handler is back on, then what you want to do, once the air handler is back on, what you want to do is to check. Once the air handler is on, you want to close, check those closed doors. You know, you close all the bedroom doors, all the rooms, check each door again, this time with the air handler fan on. Now, the rooms that just have supplies in them, like the bedroom over here, it should be a positive pressure. If you smoke the bottom of the door, it should be blowing smoke towards you. Now, but the ones that have an exhaust fan, or maybe ones that have a supply and a return in the room, the smoke could be going either way. Again, you just want to try to make it worst case, where it makes wherever your CAZ is the most negative number that it could be. So in this case, I've got the bathroom door, bedroom door, and the basement door all closed. And if I wanted to check those doors, all I would do, I'm not going to zoom in on it, but basically you can see in here what you would do if you was in the house. You'd be standing at that door, and then you would puff the smoke. If it goes under the door, in this case for the bathroom area here, that would be telling me that exhaust is stronger than the supply, because now I have a supply and an exhaust, you know, in that room. If I puff smoke and it blows back out toward me, that means that the supply is stronger than the exhaust, and it's trying to give if I open the door, it would give makeup air to my CAZ. So in this case, I can puff it here. I could probably do it. Let me see. Let me do the living room here. So I have to reach in here with the window open, but it still should do the same thing. So in this case, it's blowing back out toward me. So if it's blowing toward me, then I want to leave the door closed. All right. So now let's go to I don't think I can get the other. I might can get the bedroom here. I have to turn it at a really strange angle. If I get the bedroom here. Let me see if I can. You can't see me open the door, I don't think. Yeah, you can. I can open it there a little bit. But the smoke, you can see it's definitely blowing back into the main body there. So if so I'll leave that door closed. And then if I go down here to the door to the basement here, this house is a lot easier to move around in than a big house. So if I can get my hand out of the way here, though. Maybe if I put my hand on the other side. It's also blowing back into the room. So all 3 of those doors would be closed. Now, if I want to see the manometer reading there again, we can kind of see the numbers there. I'm going to put my window back on the front door. And just right there a little bit better there, you can see it. It's the number on the left. So that's if all 3 of those doors closed. We're like at -15. Here's the one bedroom door. The bedroom door, I'm going to open it and see what happens. it changed it. Look how much that changes just from the door there. So that's an indication that doing some undercutting or pressure relief would help. I'm going to open up the bathroom door. We'll see how that makes any difference. That also made a big difference because when we opened that bathroom door, it allowed air to come from the supply into the main body. So door closure is an issue for this one. Now, here's the next one though. So the next one is I'm going to open up this, I'm going to have to put this down here where we can see it again there maybe. The basement door. Same deal. I'm going to open it up. So there it's open, you know, and again it drops a lot. So, so when we close it back, you know, the pressure goes back to negative again. Now, so think about that. So we're at negative like 16. You know, so this is really our most negative number that we had. And at this point, we got all these three doors closed, the bedroom, the bathroom, and the basement door. And where's your return? Your central return is right here in the middle of the house. It's looking for the air that's trapped behind this door and this door. And then, of course, if this door was open, it would give it more volume. So basically, you know, doing some pressure relief would really, you know, help on this particular scenario. So, and this would be your worst case. If you had a combustion, like a water heater in this area, that's when you would fire it up, do your combustion safety test, do your spillage test first. If it passes spillage, you know, depending on what standard you're using, if you're using a 1200, BPI 1200, now you continue to test even if it fails spillage, you know, as long as you're below 70 parts per million in your ambient air for carbon monoxide. And then you do your, that's in the ambient, and then of course you check your CO in the unit itself, and if you want to do efficiency, you can do that as well for a water heater, and then those types of things. So now let's say, but you would get it into this worst case. So whatever made your most negative number, you go back to that situation. If the worst case was just with the exhaust fans on and the air handler fan wasn't on, then you would go back to whatever made that most negative number. But in this case, this is our most negative number. And a big part of that is when we got that central return and we got all these doors closed, and doing some pressure relief might help, you know, as well. So let's move our CAZ. So we're going to turn everything off. Air handlers off, exhaust fans off. We're going to open up the doors here like this. Open up the interior door. You can see down here in the basement, I got a manometer. You might be able to see the number there. I'll also set it up where we can zoom in there and you can see that as well. So, so our manometer, well, let me go back to that real quick. The manometer there has one hose, you see it there, and that goes to where? It goes, in this case, across the basement to the outside, but it could go out a window or whatever's close there. Again, as long as you can close a window or door where it goes out, you can use a little skinny probe. Sometimes we'll use these little probes, you know, like this, to go under doors and stuff like that. So we're going to go through the same process. You do your baseline test. I'm not going to go through the steps for that here, but I've talked about that enough now. So got the exterior house set in winter mode. Everything's off. Natural conditions. Blower doors up. You know, the covers on the fan. You know, all that kind of stuff. So it's faster the second time you speed up. So we want to turn on what first? Small fans, right? So that's going to be my kitchen fan, bathroom fan, dryer. Again, this is a lot easier on a small house. You get everything in one spot, but the concepts are the same. You just get a little more exercise. So got on the exhaust fans. We've got all the interior doors at this point are open. I'm going to close those, and then you would do what with the doors? You would check the ones that have fans behind them with smoke, or you can open them, close them, and see the pressure change. I'm closing those doors. Now, this is what I was talking about before, though. We have a door between the CAZ and the house. So what we'll do is we'll do it once at this door open and once at it closed, you know, once when the exhaust fans are on, then when the air handler's on. So we'll actually have 4 tests this time. We'll have exhaust fans with the CAZ door open to the house, exhaust fans with the CAZ door closed to the house, And then we'll have air handler with the CAZ door open and air handler with the CAZ door closed. So we'll have 4 numbers, and you would take the most negative of those numbers. All right. So I might even try writing them on the either on a piece of paper or on the house. We'll see how that goes. So I got a little piece of paper here. So basically, we're going to have 4 numbers there. So exhaust with the CAZ door open, exhaust with the CAZ door closed, air handler, which exhaust fans are still on, but the air handler with CAZ door open, and then the air handler with CAZ door closed. And you're going to take the worst one of those. That will be your worst case CAZ, and you go back to that setup for your when you do your combustion testing. All right. We'll fill those out as we go. All right. So now we have all those fans on. That's where we left off. We've got all the exhaust fans on. Now we need to check the doors, right? So I've got the doors up here. We have this again is the bedroom door. There's no fans behind it. So we don't need to check that one. This one over here has a fan behind it. You know, we would smoke it and see if it goes under the door. And what I'll do now is we can, I'll go ahead and do it again. It won't take me but a second. But I'm not going to zoom in, but you all can trust me. But it's actually pulling the smoke in. But what you'll also see is when I open the door, though, we'll see how it affects the pressure. So you can see there you're about minus 1.4. If I open it, it goes to 1.8. So basically, that would be showing that it was sucking smoke in, and I would open that door. If you want to see that number better, I can zoom in down there. So this is with the bathroom door open. That's with the bathroom door closed. So bathroom door closed, bathroom door open. So you can definitely see that bathroom door open is the worst setting for the door. Now, we are at the point where this door stays closed because there's no fans behind it. This door we opened, we tested, smoke went under, made the CAZ worse. Now this is our CAZ door. So our first number would be with this door open, and that's going to be negative 1.8 is what we have there. So that's going to be the first number there, negative 1.8. All right. And then, so that's our first number. The second number is going to be with this CAZ door closed. So we're going to close this. We don't smoke it. We're just going to do it once it's closed and once it's open. So that was the open number. This is going to be the closed number. Let's see what happens. Go back down to the basement here. Run back downstairs. And we're at negative 1.2. So it was a little better with it, the door closed and worse with it open. So now let's go back out to the main view here. Now we want to turn on the air handler fan. Remember that? So we turn on the air handler fan, and then you're going to check each one of those doors. And like I say, ones that just have supplies behind them, they should be blowing smoke, back into the room, and those doors will stay closed. The ones that have exhaust and supplies, those, may go either way, depending on which one's stronger. So I'm going to use my little, I'll just go through the steps here, a little smoke pencil. And then here it is. And we'll do the bedroom first. You see it's blowing back. So if it's blowing toward me, which I'd be out here where my hand is, I don't want to leave that door closed. All right. And then we'll go over here to the bathroom door again. Go check it. It's actually blowing back into the room as well. So it would be closed too. So now, if we want to see those numbers, I can go back out. So I've got the doors actually open here now, and I'll go back down into the basement. And you see the manometer here. And I'm going to close the bedroom door. It's a little more negative there. And then I'm going to close the bathroom door. So you can see that it's definitely more negative with those doors closed. So the next thing we want to do is we want to check it, with this. This is our CAZ door. It's open right now. So this is going to be our basement number. We're at minus 4 point. Well, we'll let that go for a second, and then I'll write a number down. You can use time average if you're jumping around at all. But basically, we're about minus 4.8, so I'll just go with that. And so I'll go back out to the main area here. That was 4 point, you can really read that, right? 4.8 negative. Now I'm going to close this and see what happens to the CAZ. So that's CAZ door open. I'm going to close it. Go back down in here to our basement, see how that affected stuff. So now look what happened. It went to minus 1.4. So that got, or now, yeah, 1.4. So when we closed this door, the CAZ number actually got better. And the reason that was, or why do you think it was? Give you a second, right? Think about it. Why do you think that happened? Why did it get better when we closed the door? So it got better when we closed the door because when the door is open, this return, can suck from this space, and is actually this central return is pulling from this living room area and from this basement CAZ. But when we see we're like around 4 point something there, like we had before, 8. And then when I close this off, that isolates that return up here. It's not sucking from the basement anymore, not very much anyway. And now the CAZ actually got better. So worst case, if I look at these numbers here, I had 1.8 negative, 1.2 negative, 4.8 negative, and 1.4. The worst case was negative 4.8, and that was with the CAZ door open. So now if I go back down to the basement here, you would see that we're somewhere similar to that. We're at that same negative pressure. So that would be our worst case. We would fire up our water heater, so test spillage. So you guys want to do that? So I'm going to go close this back, put this back, leave it open. We're in worst case. Go back down to the basement. Going to fire up the water heater. And, we're right about -5. Again, this is my little water heater in this model house. We're going to fire it up, see what happens. Here's the water heater. Let's see if we can see the smoke at all. Let's see. I think you can see it. It's coming right back into the house. If I take off the window here, let's see what happens. Let's see if that helps anything. I also got a basement door. I'm going to open up this door as well. So that's going to give me what? Pressure relief. And now if I go back to that basement, look at the pressure, it's like minus 0.2. So the smoke is actually going out now. But then when I close up those doors, like the basement door, look what happens. The pressure starts coming back. And then I've got the other door here. Now it's definitely backdrafted. So if we open these up, what happened is it relieved the pressure. And sometimes that's what I'll do. If I'm at a house and I got a negative pressure issue and it's backdrafting, and just to kind of confirm that it's a pressure issue, I can open up a door or a window to that CAZ and it should relieve the pressure. And if I relieve the pressure, then the smoke should go out the chimney. If the smoke still doesn't go out the chimney and I've basically relieved it or neutralized the pressure, then it's probably got something to do with the chimney itself. It might be a blocked chimney or something like that, as far as past failing spillage. So, but you can see now probably that the smoke is going out. You can see that from here actually. And then when I start to close these, I'll put the little window on first this time. See, it's starting to backdraft there. Even just that much, made a difference. Let's go back to the basement here. Let me open and take that window off. And again, this is this water heater will backdraft at a lower pressure than maybe an actual house would be. When I close that, you can see it starts to backdraft there. And then when I put on the big basement door there, it goes back to the -5, and it's really backdrafting. So in that case, none of the flue gases are going out off the chimney. So figuring out what made the pressure change that caused the backdrafting, was it the exhaust fans, door closure? And this model it's basically that central return. If I put duct leaks in it, I could cause problems like that and kind of create all kinds of different scenarios. So now turn everything off here. Air handlers off for now, and then I'm going to fire up my car. Go back down there and turn on my car. My car fired up here. And what I want to show here is I'm going to turn on the air handler fan. And you can see the smoke in the garage. I can probably put that on the garage cam there. And this right here is the door between the garage and the main body of the house. And so if I go turn on my air handler fan, you can see that it's on upstairs here. But then if I start making some leaks, I'm going to try it with just a small leak first. I got a little leak right here, you see that? And so again, with my smoke pencil, you should be able to see the smoke is actually going in there. But I'm going to close this window now. And then I'm going to start to crack this door to the garage. I'm going to kind of make like a few little leaks there. Let's see if you can see that come in there at all. It might not show up with my little green screen that I got. Let me see. There. So let me close this. You kind of see how it's kind of stagnant there behind the car, and then when I open it up, you can see it get kind of pulled, in toward the house. And if I go back out here and take this leak completely off, let's see what happens. So if I, let's go back to the basement view, or garage. Closed. Even just open a little bit, you see how it pulls that into the area where the return leak is, and then once it's in there with the return leak, it can go in the return and get distributed throughout the house. In this case, the return is in the basement, but you could actually have a return in the garage area, which would really be a bad idea. But it's not uncommon, in some parts of the country. I hope this was helpful. I think I enjoyed doing it. I enjoyed teaching this stuff, and like I say, I'll throw up my email there, and at the end, you're welcome to give me a call or email. I'll put my number there too.